All right, thanks for everyone for joining. We're going to give it another minute or so. Well, people are still dialing in, joining the webinar session.
So we're just waiting for more people to show up on the call. We had quite a few registered there, and so it's good to see all of you that have got on the line already. Currently, we have your mics muted, but we'll open that up later on when we get to questions. But if questions do come up during the presentation, feel free to type them into the box to share them with us.
All right, Jonathan, what do you think? Should we get started?
Sure.
All right, and I believe we have the session recording already, correct?
Yeah, it should be.
All right, great. Let's get rolling then. Thanks everyone for joining today's session. My name is Jonathan Darton. I'm a director at the IBI Group, and I'm currently serving as chair of the ITS Canada Advanced Traffic Management Systems Technical Committee, along with Jonathan Ford from KPMG, who will be moderating the session today. Do you want to just jump forward to the agenda there, Jonathan?
Sure.
All right, you should be seeing the agenda for today's session on the screen right now. We have two great presentations lined up for today. We'll start off with a quick intro to ITS Canada and then move on to our first presentation. Just a heads up before we begin, there are a few other upcoming webinars that are scheduled. On Wednesday, February 26th, there's a presentation on Alberta Transportation's ARWIS journey, so keep an eye out for that. And then also on Thursday, March 12th, there's a webinar on improving loss prediction using machine learning. So if you'd like any more details or to register for that, please visit the ITS Canada website or reach out to Yannicka for more information. So for those of you not familiar, ITS Canada defines intelligent transportation systems as the application of advanced and emerging technologies in transportation to save lives, time, money, energy, and the environment. Goals of ITS include moving towards a fully integrated transportation management system, improving efficiency, safety, productivity, and general mobility, while reducing threats to travel safety and security, as well as negative effects to the environment, such as pollution. ITS Canada strives to foster new ITS applications, promote government industry cooperation, and strengthen Canadian industry in order to maximize existing infrastructure. Today's webinar is brought to you by the ITS Canada Advanced Traffic Management System ATMS Technical Committee. That's one of 5 established technical committees within ITS Canada. The ATMS Technical Committee has been created to share best practices and technical information, promote the deployment of intelligent transportation systems, encourage open interfaces and standards, and explore innovative systems deployments to increase efficiency and improve productivity. Committee members have the opportunity to be actively involved in priority setting and steering of ITS Canada's activities within this area. Transportation management providers and private sector representatives interested in learning about or sharing information on related technologies and industry trends and playing a role in related policy advocacy are encouraged to contact Yannicka from ITS Canada or any of the committee chairs. That would be myself, Jonathan Darton, or Jonathan Ford, if you'd like any more info. In terms of the format for today's session, we'll have time for a few questions between presentations, as well as at the end of the session. At any point, feel free to enter any questions through the chat window. And at this point, I'd like to pass it over to Jonathan Ford, co-chair of the ATMS Technical Committee, to introduce our first presentation. Thanks again for joining.
Great, thanks, John. So my name's Jonathan Ford, as John Darton mentioned. I'm with KPMG's Global Infrastructure Advisory based out of Winnipeg. And today we're excited to have both Jascha Franklin Hodge and Michael Schnuerle with us today to share more about open source collaboration through data and how it's enhancing city traffic management action and public policy outcomes. I'll just switch over to the next slide here. So Jascha Franklin Hodge is the Executive Director of the Open Mobility Foundation. This city-led foundation helps government and industry collaborate to develop open source tools and data standards that support the adoption and regulation of emerging mobility technology. He previously served in the cabinet of Mayor Martin J. Walsh as Boston's Chief Information Officer and led the city's Department of Innovation and Technology, where he managed a team responsible for the city's efforts to build exceptional user-centered digital services, harness data to improve quality of life, empower city employees with effective technology, and improve access to the internet and technical skills training for city residents. Previously, Jascha co-founded the Blue State Digital, where he oversaw the development and operation of the BSD tools, a fundraising email and CRM platform that raised over $1 billion and powered the digital presence of President Barack Obama's 2008 and 2012 campaigns. And Franklin Hodge, Jascha, is a visiting fellow at the Harvard Kennedy School, and he's focused on mobility, technology, and public policy, and as well as a consultant to the private sector on new mobility and smart cities. He additionally serves on the boards of Livable Streets Alliance, Tech Goes Home, and Massachusetts Information Technology Exchange. So there's a lot more that we could go into, but we'll hand it over to Jascha to continue sharing. So I'll just send over his screen 1 second. So Jascha, pleasure for you to be here and to join with us and tell us about the good things the Open Mobility Foundation is up to.
Hi, everybody. Well, thank you for that introduction. You got the long version of my bio there. Let me just make sure the screen share is working. All right, there we go. Well, thanks, everybody. Appreciate you being on the webinar, and want to take this opportunity to kind of introduce everybody to what we're trying to do at the Open Mobility Foundation, and invite you all to get involved if it seems like something that would be relevant for you. I'll start, before I get into the details of what we do, I'll start with a little bit of context setting. You know, most of this I don't think will be news to any of you if you're working in the transportation space, but there is a lot that is changing right now. If you look back over the last 10 and especially the last 5 years, you see an explosion of new modes, new services, new business models that have emerged on city streets as technology has started to reshape how we get around. And this is sort of, you can see it in the advent of these new modes, but you can also see it in numbers, right? And I think it's become clear, especially when you look at things like ride hail, just how significant these services are starting to become, especially in dense urban areas. Same thing is happening with micromobility. The advent of scooter share in 2018, you had this kind of like slow, steady growth of traditional bike share services, and then pretty much overnight that ridership doubled as commercial scooter services started to operate. So again, this really kind of dramatic growth that's reshaping city mobility. And there's a lot more on the way, right? There's the technology continues to evolve. There's really exciting things happening in autonomy, in aerial, and we're seeing sort of this like really wide spectrum of form factors and use cases and business models starting to emerge. And I think it's safe to say that nobody really knows how this is all going to play out, but there's a lot to be excited about if you believe that these technologies can improve transportation for people. But the challenge here, right, is if you're a city government, a Department of Transportation, anyone in the public sector, this is a lot of change to manage in a very short span of time. And so the question is, how do you do it, right? How do you make sure that you are minimizing negative externalities, maximizing community benefits as all of this change happens, that you're regulating in the right ways, but not over-regulating and stifling innovation? It's a challenging position for the public sector to be in. And so the lens I like to use when I think about this and think about the mission of those public sector folks is this concept of public space for public good, right? It's pretty simple. This idea that, a city DOT, their job is to make sure that the limited real estate we have for transportation, that the curb, that the streets, that the sidewalks are maximizing public benefit. Now that's a really nice sort of one sentence phrase, but it kind of, it's a little vague, right? So what does that actually mean when you say, especially a concept like public good? Well, a lot of cities are starting to ask this question of themselves. And so they're doing these kind of big planning exercises. They're looking at the technology landscape. They're looking at their own values and priorities. And you see it kind of boil down into these different types of strategic plans. And you don't have to read all the details of this because it's kind of an eye chart. But what I realized as I've started to read through a lot of these plans is that there are some big themes that emerge across all of them. And this to me has kind of come to be the substance behind this vague idea of public good. And the big themes that we see are safety, equitability, accessibility, and sustainability. These are things that almost every single city addresses in one way or another as a core value that they want to preserve and promote as these new services start to emerge. And in some cases, this is not just about sort of looking at the future, but it's also looking at the past, looking at the things we got wrong when we rebuilt our cities around the automobile and the consequences that created when it comes to things like safety and equitability and sustainability. We have some mistakes to correct. And so I think cities are starting to look at this technology landscape and say, great, let's learn our lessons from the past, and let's think about how this moment of transformation can be an opportunity to really kind of revisit that idea of the public good and double down on both fixing things we got wrong and making new technologies the thing that can bring a great deal of public benefit. Now, how you do this is, of course, the question, right? There's a lot of traditional infrastructure for managing public rights of way, signage, parking meters, all sorts of kind of mechanical devices and communication devices. But when you look at these new services, they all have something really, they have three things in common that I think make our traditional management tools a challenge or limit their ability to be effective. All of these new modes, they're digitally native, they are data-driven, and they're highly dynamic. And so when you think about things like stop signs and parking meters, they are none of those three things. They are not digital, they are not dynamic, they are not typically particularly data driven. They tend to be things we put up once, they're very static. We maybe every few years we evaluate, performance or pricing, and we make adjustments. But that doesn't necessarily lend itself to being an effective tool for managing these new services. Now, some of the new infrastructure that we're going to need is physical infrastructure. And you have organizations like NACTO, the National Association of City Transportation Officials, that are doing really interesting work to in this example, to like reimagine what a streetscape might look like in a world of ubiquitous autonomy, of a focus on moving people and creating good human experiences rather than storing and moving cars. And so there's this, there will need to be some real transformation in our physical infrastructure and our built environment to accommodate this world. But we believe that there also needs to be a set of digital infrastructure which will enable cities to do this job of managing public space for public good in this new era. Now, we are not the first people to think about this, and there's been a lot of good work. These are some of the examples of the documents and research and investigation that's happened into this topic. Much of this through line here, though, led to the creation of the OMF. And as you'll hear about in a minute, our core service or core product that we produce right now is something called the Mobility Data Specification, which came out of this planning work that the city of Los Angeles was doing for this future of new mobility. So with all that preamble, I'll kind of get into the meat of like who we are and what we do. So we are a nonprofit open source foundation with the mission of building digital infrastructure that helps cities manage public space for public good. In practice, that means that we create and we manage data standards and open source software, which enables cities to do their job of managing public space. We're structured as a membership organization that has both public and private sector members. And that's a very intentional design because we believe that the way that new mobility services will grow, will prosper as businesses, but also will benefit communities is when there is meaningful collaboration between the public and private sector, mobility providers, cities, companies that are building technology which can act as the connective tissue in this new ecosystem. And we want all of them at the table as members or participants in our work. We also believe that we have a role to play in helping to form a sort of sense of shared vision across the different sectors and to build some of the relationships that will actually allow public and private sector to work together towards shaping this future that we're going towards. It's easy to talk about these questions in these institutions and these issues from the frame of institutions, a city government or a company or whatever kind of organization you're talking about. But ultimately, there are people who are on the front lines of this work in city halls, in companies all over the world, and we want to help create some of the personal relationships that allow those folks to get to know each other, to understand the perspectives and priorities of each other, and to hopefully in doing so smooth the path to these new modes of mobility becoming commonplace. So a word about our structure. I said nonprofit open source foundation, and if you come from the sort of software world or the internet technology world, you probably know exactly what I meant when I said that, right? There are a whole series of organizations like Mozilla and Linux. They're much larger than us, but they are similar in their design because what they do is they oversee a body of software and a number of data standards that are used in the operation of internet services and of various types of computer infrastructure. And they're built around the concepts of open source. And I won't go into a deep dive on what open source is. You can always look it up. There's lots of great resources online. But ultimately, what we are is a place where public and private companies can come together under an umbrella that prizes transparency, participate in open participation. They can create common standards, they can create software, and they can do it in a way that is modeled after these sort of other types of open source projects that doesn't that actively encourages sort of free licensing models and unrestricted access to technology. But even though we're a nonprofit and even though we're based on open source, we ultimately believe that our success is rooted in helping to create a business ecosystem. If you look at any of these other foundations, there is this enormous ecosystem of companies that exist to build on top of the open source software, to sell it and make it available with services to companies, to create value add products and services around the open source. And so we think that that's actually a crucial part of what it is that we have to do to be successful in this model. We have members. This is a slightly out of date slide. You can see the URL up in the top if you want to see our current membership, but we have 23 public sector members and I believe 7 private sector members. Right now, we have a number of philanthropic partners and also some great partner organizations who serve as advisors. You know, some leading folks from the transportation space, including ITS America and a number of other organizations. As I mentioned, our primary output right now is the Mobility Data Specification. So this is an API that connects mobility companies with local governments. Primarily, it's focused on micromobility today, so bikes and scooters. And what it does is it allows cities to get information from companies about the operation of their services, where their vehicles are, what trips are being taken. This information is not intended to identify individual riders. It's all anonymized, but it does allow cities to understand precisely how services are being used on their streets and to make sure that their permit regulations for companies, things like caps on number of vehicles or restrictions on where they can be parked or ridden, that those are being followed. Currently, MDS is in use in more than 90 cities around the world. And there's a marketplace of tools, you know, back to that idea of a business ecosystem that has emerged around MDS. My last count is that there are at least 8 companies who exist really primarily to build value-add software on top of this open specification. Most of those are companies that sell that software to cities, so it helps cities ingest raw data and then turn it into useful analysis, visualizations, and insights that allow cities to use that data in policymaking. But what's interesting about MDS is not only that it solves problems for cities, but also that it has solved a problem for mobility companies. Because one of the biggest challenges facing scooter companies as they grow is the need to move quickly as they enter into a new market and to avoid sort of one-off costs, right? They're seeking scale and the economies that come with it. And so by having a common standard for how they interface with local governments, it allows mobility companies to avoid having to do a lot of bespoke work to provide one-off data reports to each city they go into. So it reduces their cost and complexity, and it improves their time to market. And we think, you know, I highlight this because I think it's a really important aspect of what has made MDS so successful so quickly, is that it works for cities, but it also works for companies in the industry. I'm going to talk a little bit more about some of the more details of the use cases for MDS in a second, but I just want to talk a little bit before we get there about how we work and how we function as a membership organization. So as I said, we are open source. We are led by cities. Our board is comprised of city transportation leaders, but we have strong private sector participation in our governance. All of our work is done in the open through working groups that anyone can join. You have on the right the little Hollywood Squares style Zoom meeting of one of our working groups. It's a few months old. And all of our code and all of the development we're doing is happening through GitHub, where anyone can see the work, they can weigh in. It's a very much, you know, by anyone can be a part of the technology that we're building. And lastly, everything is, you know, open source licensed, right? So this is critically important to make sure that we have a truly competitive ecosystem forming. And that gets to some of our key principles, right? We want competitive marketplaces for mobility services and software tools. We think that benefits cities. We think that benefits ultimately everyone in the ecosystem. We believe in data standards as a way to create compatibility amongst different tools and technologies. Anyone who's been around the transportation tech world can tell you all about the kinds of lock-in that can develop, especially for public agencies where they get in somebody's technology stack and they can never leave. We don't think that that's a good thing, especially when taxpayer money is involved. So our aim is to create a interoperable kit of parts that allows cities the flexibility to buy from different vendors, but to still have things work together as a cohesive whole. Modularity is really important because not every city is the same. They don't all have the same priorities. They don't all have the same regulatory approaches. So we view the tools that we're creating as a kit of parts that cities can pick and choose from, but which ultimately add up to a predictable set of interfaces for mobility companies so that they're not having to deal with a bespoke thing in every single city they go to. Fourth is privacy. Anytime you're dealing with mobility data, even if it's anonymized, there is risk to individual privacy. Anonymous data can sometimes be re-identified, and the more detailed, the more trip specific it is, the higher that risk. So part of our job is to design technology in ways that minimize negative risks to privacy and to educate our members and users about the risks and how to mitigate them. Lastly, and we've talked about this a few times, but we work in the open. We have a transparent participatory process. Whether or not you're a member of OMF, you're welcome to be a part of what we do, and we aim to make all of our work something that the public and anyone who's interested can see and comment on. Membership in OMF, we are a membership organization. We are free for public agencies to join. Companies do pay annual membership dues based on their size. If anyone is interested in talking about membership, feel free to reach out to me directly. Members are allowed to serve on our technology council and on various committees, which are really where we decide the direction of our technology, the big kind of long-term strategic work that we're doing. We have working groups which are open to the public, whether or not they're members. And lastly, we put on a number of events for members to try to build those relationships and that shared vision. Examples of those, we ran a half-day conference in Los Angeles in November that really showcased some of the great work that our cities and commercial members are doing. At our last member meeting at TRB a couple weeks ago, we had breakout sessions that were focused on planning around new modes and other areas where we might work. This was the breakout session on ride hail and exploring the policy issues and the potential value of data. So we try to create these spaces where public and private can come together, not in a kind of regulated conversation, but instead in a where are we all going conversation. And we think it's really important to have those spaces. So I want to talk in a little bit more detail about mobility data specification and specifically how it's being used right now and why we're excited about this. So I'm going to steal a slide from Michael, so you might see this slide again. But this is an example from Louisville, Kentucky, of using MDS data during an infrastructure planning project. So thinking about if you're reconstructing a corridor, how you might use data to tell you what trips would be affected by that reconstruction and the decisions you make there, so that you can understand what parts of your community might benefit from the changes you're making or who need to be consulted about the impacts of those changes. This kind of mobility data is an incredible tool to add to traditional infrastructure planning. I'm seeing something in the chat about sound, so I'm going to pause for a sec and just make sure that we are that folks can hear me. Give me 1 second here. Jonathan, are you able to hear sound?
Loud and clear on my end.
All right, excellent. All right, I'll keep going. Sounds like
if anyone else is having issues, just feel to write it in the chat box and we'll go from there.
Okay, I'll keep moving. So this kind of data is really valuable for sort of the kind of big infrastructure planning projects, but it's also used in very localized contexts, right? Understanding, for example, where there might be an excess demand for scooter parking and using that to identify locations for a designated parking zone. That would be one example. Looking at the speed differential between cars and micromobility vehicles on roads that have high traffic volume to identify corridors where a bike lane might be a priority intervention for safety. This kind of data is just incredibly useful across an array of things for infrastructure planning. One of the things that's really exciting to me about MDS and how it's changing the way we do policy, anyone that's been around tech and government is very familiar with the thing where policymakers go off, they write a law, they create a regulation, and then when it's all done, they come to the technologists and they say, this is our policy, go implement it with tools. And of course, that often leads to complicated and sometimes not particularly functional infrastructure or functional technology infrastructure to support those regulations. What we're seeing with MDS, because it existed when these rules were being written, is we're starting to see regulation get written with the data standard in mind. So instead of saying you will collect data, laws are being written that specify a format, and with that, the rest of the policy that gets written around those data are able to take advantage of the same of the learnings that other communities have had in using this data, the tools that other communities are buying or building to support them with this. So it's starting to invert the direction of how we make policy so that technology is there at the outset in that conversation. We're also seeing policy-making approaches because dynamic and real-time data is available. We're seeing policy-making approaches that rely on data for implementation of the rules. So as an example, many cities have a cap on the number of scooters. And instead of making that a static thing that changes once a year, you're seeing cities use data about vehicle utilization to dynamically adjust that cap on a much more rapid basis. If vehicles are being heavily utilized, the cap can go up, and if they're not being utilized, the cap can go down. That's something that's only possible when you have access to data. We're also seeing this is another slide I stole from Michael, but this is this idea of digital native regulations. One of the things MDS does is it allows cities to publish their regulations about restricted riding or parking areas through a standardized API. Even things like slow speed zones where the scooters are required to operate at a lower speed can all be published using a standard API. So instead of the regulatory process starting with a PDF file with a map in it that gets emailed out to all of the companies, there's an API call that they can make, and it can automatically integrate whatever the local rules are for the service can be automatically integrated into the operation of these mobility companies' apps and their services that they're building. It really kind of brings the government's role in managing this world into the digital era and allows them to operate in the same language and with the same kind of tools that the companies themselves are using. Lastly, we're starting to see some really interesting experiments around market incentives, which become possible when you have detailed data. So an example, one of the things that a lot of people are very excited about for micromobility is its potential for first last mile, to be a first last mile solution with public transit. And so this is a pilot that Lyft was conducting of offering a discount to riders who start or end near a transit station as a way to kind of make for a cheaper overall journey and to incentivize people to use micromobility for that first last mile. I think we're just starting to scratch the surface of what's possible here in micromobility and in other forms of mobility. But it's a really rich area of exploration as these things like MDS start to give governments and regulators tools to really understand and influence the market dynamics of the services that are emerging. So the last thing I want to talk about, and then I'll wrap up, is just kind of where do we go from here, right? We've talked a lot about micromobility, but ultimately the vision that we have for a data and API-enabled, government is one that I think is in some ways even more exciting in a few other domains beyond micromobility. We're exploring what role this kind of data could play in autonomous vehicles, the testing programs that are underway as they start to get commercialized. How do cities start to get data that helps them understand where they need to make infrastructure changes like pickup and drop-off zones? How do we maybe apply that in the context of ride hailing, where There's some significant externalities that cities are struggling to manage. What kind of data helps them understand congestion impacts, emissions impacts, labor and wage impacts of these services, so that they can write policy that ultimately furthers the public good. Many communities are starting to explore the idea of digitizing the curb, whether that's simply mapping the curb in a digital form and the regulations in a digital form, or potentially creating sort of smart curb or dynamic uses for curbs. It's a place where we're seeing our members start to do some really interesting explorations, and so we're asking the question of what digital infrastructure is missing in this space, and is there a role for the OMF to create or support some of those efforts to build that missing digital infrastructure. Freight and logistics, it's often overlooked because passenger transportation is so sexy, but the reality is that we have a huge surge in e-commerce, in on-demand deliveries, and it is having impacts on cities around the world. Now, there's some really positive benefits to this, but we're seeing cities start to take more seriously the idea that they need to manage the impacts and operations of some of these emergent delivery platforms. And so we're getting experiments in things like curb reservation or alternate delivery vehicle types or incentivized off-hour deliveries. These are things that cities are trying now. And again, this is a place where we see the potential for there being some missing digital infrastructure that enables cities to do this exploration work and to do it at scale, and to allow it to scale when successful models are identified to other domains and other places. And then lastly, road pricing. This is a photo from Europe, because that's the only place that, for the most part, that does road pricing these days. But it's just certainly not in the United States in any meaningful way yet. But we're finally starting to see the dam break on this. New York is implementing a congestion charge in Manhattan. LA is exploring road pricing. There's even some states like Oregon and Utah that are starting to dip their toes in the water. And so again, it's another place where we see a lot of public sector interest. We think that there are some missing pieces of technology infrastructure. And so we are looking at whether there's a role for us to play in helping to build that. So that's a lot of stuff, so I'm just going to wrap up there. This is where you can find us. If you are a software person, please check out our GitHub page, get involved in our working groups. You can sign up on our website if you want to stay in touch with us or you want to talk to us about membership. But we are really excited to have you reach out and participate in any way you can, and excited for where this goes. So I will stop now, and I think we have maybe time for a few brief questions, and then we'll turn it over to Michael.
Great, thank you very much, Jascha. Thank you for that great presentation. So if you do have questions, feel free to write them in the question box, and we can share those with Jascha. And if we don't get to it right, during this brief question time, we can always bring them up afterwards. So looking forward to having your questions. I think you briefly mentioned some of the tools that were there. Are you able to provide sort of a high-level overview of the software tools that you mentioned? Is this tools available only to OMF members and partners?
Yeah, so the tools are, there's a mix of things, right? So we have the data specification, which is really just a definition of an API that is available to anyone. Anything we produce is freely available and licensed. So that's something that's in use now, widely in use now. We're in the process of developing and releasing a reference implementation software package that essentially is a set of code that would allow a city to, for example, stand up some of the APIs to collect data, to do some of the compliance analysis that cities want to do. We have a draft version of that right now in GitHub, and we're targeting April for our first sort of official release candidate for that. There's also a number of open source packages that individual cities have released. Those that have done their own development of analytics tools or data management tools have released them, and you'll find some of those linked on the GitHub page. If you go to that URL and you look at Mobility Data Specification, you'll see in there links to some of the city things. There's also a number of private sector companies. I mentioned, I think 8 companies. You have companies like Blue Systems, Lacuna Technologies. They're both members of the OMF, and there are others like Ride Report and Populous and Remix that are building, Via Nova in Europe, that are building technology on top of OMF. So there's kind of a plethora of both open source and private sector tools available to people.
Sounds great. We had a question from Brampton. Do you have any Canadian cities already participating with the OMF?
We do. So the city of Kelowna is a member of OMF, and the APIs are in use in a number of other Canadian cities as well. So we know that MDS is working in Canada, and we're in conversations with a few other cities right now about joining officially as members.
Sounds great. So in addition to participating and, say, providing input on the direction of MDS for, say, a private industry partner, what are some additional benefits that would come from being able to join the OMF?
Sure. So, one is just being able to be at the table in our member meetings, with our member events. We are a group of, some of the sort of cities that are the most forward-thinking in terms of transportation, and we have heard time and time again that there's a ton of value that companies find in being able to, sit with those folks to share their ideas, to hear their priorities. We also are, we're putting together for this year a kind of full calendar of member events, but we anticipate doing, in addition to kind of in-person meetings and get-togethers, we anticipate doing webinars and other types of events that allow our public and private sector members to tell their story, to share some of the work that they're doing, and to kind of be a part, visibly be a part of co-creating these tools and technologies. So all of those are part of this, but ultimately, anyone who's a member gets to be sort of formal participants in governance. We have Technology Council, which some of our commercial members sit on, which is really the key body besides the board of directors in making big picture decisions about the OMF. We have committees and working groups where anyone can participate in a working group, but we have steering committees for those working groups, which are the voting members who get to decide what actually gets released or what our priorities will be in a given release cycle. So that is another role for our commercial members to be able to participate in those kinds of decision-making things.
And just from the other side, having come from the inner workings of a city with Boston, and seeing the challenges and, seeing the significant focus on the physical side, and now there's this growing awareness of the digital infrastructure, the APIs, the open source, the development. Do you have any advice for a municipality who, sees the value in this, on how they could maybe bring that awareness of the digital infrastructure to their organization?
Yeah, I think, it starts with being able to, it starts not with technology, but being able to articulate what your goals are. Technology will not solve all your problems. I think we've proven that pretty soundly at this point. In fact, it might create some new ones depending upon how it gets implemented. But start with your goals, start with your values, and then reach out to other public sector folks who have similar challenges and similar priorities. And that can happen through the OMF. Being a part of this organization gives you access to all of those other cities who are all doing their own experiments, they're building their own tools, they're learning as they go about what policies work and what don't. And so becoming part of a community of people with similar challenges is, I think, was certainly for me as a CIO, one of the most valuable things that I was able to do for Boston and to help myself in that job. But also, I think there's a lot of internal work, and depending upon what role you play in your organization, whether you're in a transportation department or a technology department, or you're sitting as a bridge between those two, there's a lot of education that has to happen. And so we as an organization hopefully have resources and tools that make it easier to do some of that internal work. But ultimately, we recognize that this transformation from kind of just traditional analog modes of work to ones that are more digital and more data oriented, this is a long process, and every organization and every city is going to take that journey in their own way. But there are so many great examples to learn from, and I think ultimately this will only happen if there are really great champions who are inside organizations making the case, but who are also plugged into their peers around the world and drawing from their strengths, their experiences, and the learning that's happening together.
Excellent. And in that regard, it's good to have Michael Schnuerle here as well to present on the topic, and really provide that insight, right? That cities and organizations no longer have to go it alone, but that opportunity to collaborate with that digital infrastructure is there. With one last question from Michael DeSantis, has MDS been considered or applied to mobility as a service? And if so, where?
Yeah, I mean, to my knowledge, it's not sort of been a formal part of anyone's MOS kind of program, but I think certainly the data that's available through MDS can be, I think, a really useful part of understanding how a mode like micromobility fits into a larger MOS concept, right? How do these pieces stitch together? How do the modes stitch together? Where and how does one mode serve another or help create a multimodal journey? I think as we expand the scope of what we do, both modally and also in terms of the type of data that we capture, the type of services that we enable, something like MDS could become a really important underpinning for a MOS service. But ultimately, we're not there yet, and I think some of the MOS business models are still emerging. So we're excited to be a part of that conversation and work with the other organizations that are pursuing other aspects of the MOS vision.
Excellent. All right. So if you have further questions, feel free to write them down. There'll be an opportunity once we get through our next presentation to have those come up. So feel free to type away, and we'll get to those questions next. But thank you very much, Jascha, for your presentation. It's a great presentation, and you've answered a lot of really good questions just by going through your presentation. But now we'll switch over to Michael Schnuerle. And let me just move on to the next slide, and I'll just briefly introduce him. So Michael Schnuerle is Louisville's first Chief Data Officer in the Office of Civic Innovation and Technology, and is working to use data to improve government performance and transparency with responsibility for open data, citywide data strategy, and fostering employee data-driven decision-making. He spent the first years, 14 years in civic tech and 24 years working on internet projects. His first product was as an entrepreneur, was an online crime map built upon open record requests and Google Maps in 2005. But this grew into an open data advocacy and building civic services around real-time transportation, public safety, geocoding, data standards, and APIs, and led to Michael co-founding Louisville's first Code for America Brigade. His latest focus is collaboratively building common open source tools with other governments and partners through the Open Government Coalition and serving on the Open Mobility Foundation. So it's great to have Michael here with us. When I was with the city of Winnipeg, Michael was a good contact for me to reach out to ask various questions about things that they were doing. And his idea of collaboration is something that he definitely embodies. So it's great to have Michael with us. So Michael, I'll pass over the screen to you and we'll get into your presentation.
Thank you, Jonathan, for that introduction. Very nice of you. And I'm going to bring up my slides here. I also want to say thank you to Jascha for his presentation. Looking at it, trying to look at it with fresh eyes makes me realize how important this work is and how groundbreaking it is. I've been involved with the Open Mobility Foundation for a little while now, but trying to look at it fresh, I feel like I would be really excited if I just saw Jascha's presentation. And I'll talk about why in my presentation. So I'll talk about how the OMF really helps cities with our operations and our policy enforcement, and give some examples of other successful open source city software projects. So first I want to talk about e-scooters in Louisville. That's me riding down Main Street on a scooter. And
just one sec, I'm not sure if your screen's presenting quite yet. Might just be mine being slow, but
sorry.
There we go.
Yep, my fault. Yep. So that's the picture I mentioned that you were very eager to see. And here's some snapshot of our operations. This is from a few months ago, but it's typical what you see here in Louisville that you see in other cities. We have multiple operators with certain caps of vehicles. We've got about 500,000 recorded trips in a year and a half, and average distance is just over a mile, which is also typical. It's used mostly for short trips, although interestingly, from one operator, one of the 4 you see there, in the first 6 months, we had over 5,000 riders with more than 30 trips, which shows that some people are using it as a form of reliable transportation. So I want to talk about this from the perspective of James Graham. He's our mobility coordinator in public works. So he's basically the one person in all of our government that is tasked with managing the relationships and with the companies, the data that's coming in, the policy that we have, enforcement of that policy, et cetera. So he's got a lot of work to do. He does the permit fees as well, looks at outcomes, looks at equity, fields complaints, et cetera. He's got a lot of challenges. Enforcement needs to be real time, not after the fact. Our permit fees are structured based on, dynamically based on the scooters and usage, like Jascha mentioned. And complaints come against from a bunch of different sources. Outcome is time and data intensive. He's only one person. But MDS can help him. MDS contains for these trips real-time and historic vehicle status and trip information. It relies on open standards, so there's an open source community behind it, which means redeployable tooling, and it can support most of these use cases. But can it really help James? So James has a master's degree in GIS, but he didn't even know what an API was before working with this. So that's kind of where I come in, and how, even though MDS is an API, how MDS can help James. So I'm a data generalist. I came in to help James make sense of MDS, and also I helped write some of our city policy initially to make sure that we had the data we needed to do what we wanted to do in terms of safety and equity and enforcement, and MDS was the solution we landed on early on. So his audience is, why does he need this information? He needs it for our council to approve even the operation of the scooters. We use it for grant funding and other funding sources. Operations, like I mentioned already. Our planning team uses it for prioritizing infrastructure projects. And then we also publish some data to the public so that we can be accountable for our decisions. People can see where rides are taking place, and just help understand the scope of this operation. So I'm going to go through some of these over the next few slides. Permit fee assessment is one area. On the right there is our policy where we set up our fee structure, which is not that dissimilar from other cities. But more recently, we did change it where we tried to make it more favorable to the operator, where it's not just based on number of vehicles deployed per day, but actually vehicles ridden that were deployed per day. But that made a harder calculation, and we wouldn't be able to provide that without the detail of MDS. Jascha mentioned this. This is our kind of our digital enforcement. This is done in GIS and pushed out to the companies that way. One interesting thing about the restricted zone on the right in red, that is actually our American printing house for the blind. So there's a lot of visually impaired people that work and travel to there. And so they asked us early on to make that a restricted zone because of tripping hazards and ride hazards. And we were able to enforce that, and it was something we couldn't necessarily anticipate as a city government. So, but we were able to enforce it pretty easily by using APIs like MDS. So we also use it for equitable distribution, like many cities. This is a map of our city. The lighter areas are the people with less income, or sorry, this is property values. And so if your fleet's over a certain size, we basically have a percentage of the fleet required in areas of town that have less income and less property values. And as you might not be able to tell much from this map if you're not familiar with Louisville, but where all the density is, those spikes, that's where scooters are being placed by the companies. But if you go west of there, which is to the left in this map, you can see there's not a lot of placement. This was before our equitable policies went into place, before the scooter companies hit their caps. So this tool allows us, and the data allows us to make sure that that's happening, and allows people who might not have had access to this, these devices, to give them access to it. And then another example is just looking at where trips are taken based on the speed limits of roads, and how can we handle our infrastructure improvements better to more accommodate riders when it might not be safe to do so on high-speed roads. And that has actually led to some of the improvements we were working on, just like the one Jascha shared. We also use it for time of day riding. We have a restriction on nighttime rides out of a safety concern. So this helps us enforce that. You could argue whether that is a good rule to have or not, but it's something that our community really wanted us to enforce. And then this is another detailed view of a corridor that shows where drop-offs are happening using MDS. And so we were able to take this, and wherever you see those sort of clusters of peaks of drop-offs, that's where we're placing our designated parking areas, and working with the companies and using APIs to get that information out to the companies and make sure that we drive people that are riding the devices to those parking zones based on the data. And they'll look something like this. This is not ours yet. We're going to do it in the springtime. We also use it to justify the bike lanes, like I mentioned, and we can overlay our own bike lane network to look at that. Interestingly, maybe in Louisville, we have some restrictions on what we're allowed to do with bike lanes. So what you see at the bottom is some of the best we can do. We can't do parking protected bike lanes here in Kentucky. And we also look at travel corridors and origin destination information to look at where people are moving, which can inform our bus network as well. And we're sharing that information with our transit agency. So that shows an example of how MDS data is used, and then how I helped connect that to tools that we have. One of the tools I want to mention that we're using, there's a company called Stay. You can see their logo at the bottom right there. All those screenshots you saw of the trips and the hot spots and the 3D images, that all came from their platform. So they're a private company. They are an OMF contributor and sponsor. But they're building their platform on top of MDS, one of many companies that are doing so. And for us, they were a good fit because they were not just about MDS and transportation. They also were much broader, and they kind of serve as a data warehouse in the cloud for us. So by aligning these three entities within the city and our operations, we're able to manage all the scooter information with the help of MDS. So I want to mention some other open source tools and ideas that have been successful. So one of my job responsibilities is to work collaboratively with the public, researchers in universities and other cities, like Jonathan mentioned, and companies, private companies, to do projects. And many times when we actually get down to it, they end up being tech projects of some sort, and we manage that on GitHub in the open. Here's a few different resources for you. So we have our city, our main city GitHub account. We have our innovation account, which is the one I run, which has some more innovative, less traditional projects there. We use an open source platform for our open data website. It's called DCAN. And that's a typical model as well, where a city is using open source for their open data website or other websites. And the benefit there is we do pay a company to manage that for us, to do patches and upgrades, but part of that fee goes towards building out features to the open source platform and as soon as we pay that fee to the company to build out the features we want, everyone else in the network gets that feature automatically with their next upgrade. So by supporting open source, you can really, I think it's really cost effective, it's transparent, and we can get changes out to the community and it benefits everyone. The Open Government Coalition, let me see if my next slide is, yeah. I'll mention that a little bit more in the next slide, but it's not an official nonprofit, but it's an organization that has governments collaborating on building open source tools together. And I'll mention an example of that in the next slide. And of course, the Open Mobility Foundation. So this is an example I wanted to point out. This is something that Jonathan and I have talked about in the past. But basically, Waze, which is the navigation app, they give data to cities, hundreds of cities right now. And that city data that they give to cities is hard to manage. It comes in like a fire hose. You need a lot of infrastructure to set it up. Some DOTs have paid $500,000 to set up the infrastructure just to process the Waze data coming in. So we thought, with the help of the Open Government Coalition, let's just get a bunch of cities together and build it collaboratively as an open source database platform to understand that data and save it for each city. And then we won't have to reinvent the wheel in our own silos every time. So this project, we've got 80 governments on board with it. There's probably 20 cities or governments, including entire country governments like New Zealand and I think Peru is another one, the Netherlands, but they're basically using it for free. And the only cost is $200 a month, which is the cloud cost. So this is an example of a collaborative public-private partnership of open source development that led to a great outcome for cities. And on top of that, we also then have integrated some traffic study tools built on the free Power BI tool. There's a blog post about it there, but by layering free tools on top of the data infrastructure that exists through this open source platform that we built, anybody can then grab that same file and connect it to their own data source and have these tools at their fingertips. And we use these, I mentioned cost savings. Instead of paying $50,000 for a traffic study, we will just tap the Waze data and do it on demand without any forward planning needed, retroactively. And the outcomes are, we've done some comparisons where they're 90–95% equivalent to paid traffic studies. So we feel pretty confident that the data is worthwhile for planning purposes, and it saves us a lot of money. I mentioned our open data website, which is run on DCAN. There's a screenshot of it there and the URL. And I also want to point out that in 2018, Louisville was the first city to publish MDS trip data. Now it's a fuzzed version of the detailed data we get from MDS. It's fuzzed geographically, spatially. There's some other things going on. We've corrected for errors as well. But only 4 cities have published this information, and I hope more cities do as well, because I think it's a good transparency effort and data sharing effort that is made possible by MDS. So there's my contact information. Let me see if there's, yeah, I think I've touched on all the points that I want to touch on, but I welcome any questions right now from anybody.
Well, thank you very much, Michael, for your presentation and sharing a little bit about the various use cases where you're using, MDS to support the management of micromobility within your city. Just a question, and feel free to write down questions in the question box there if you have them. I'd love to get to those. And after we go through a few questions with Michael, we'll open up to everyone, to all the presenters. So feel free to write your questions there. Michael, knowing that you worked with various other cities and you see others going through various micromobility opportunities or challenges, where do you see Louisville, had they not used MDS and just had scooters? What are some of the challenges that others are facing by not having a mobility data specification in use?
I can talk about that hypothetically. So without, I would say though, like Jascha pointed out, there's 90 cities or so using it. I don't know of any cities that have scooters that are not using it. Maybe Jascha does. But without it, I think you run into multiple problems. You run into that problem he mentioned where the companies themselves that are providing the data that the cities will ask for, they have to do these ad hoc reports, and it becomes this custom work that they have to do and they have to spend their time on, as opposed to just allowing that city to have access to standard reports, standard data, standard historic information, and real-time information. So I think, one, it's harder for the companies. Two, I think the cities are probably, if they're requesting something ad hoc that's not aligned to a data spec like MDS, they're probably missing out on some information and some insights and some enforcement mechanisms. And third, they're missing out on that ecosystem of tools that have been built on top of MDS, that the open source ones that the OMF has a version of and will improve upon, and also the paid ones like Stay and other tools that are out there and other companies that are able to ingest that for that city and make sense of it. So Josh, I don't know if Jascha wants to speak up if he knows of any city that has some scooters that's not using it and how they handle it.
I don't, to be honest. I mean, I think it's MDS is certainly in use in the majority of cities that have scooters. But I think, Michael, you hit on all the key points, which is, it's cities, even the biggest cities don't have the capacity to build all of their own technology tools or pay for someone else to build custom tools. And so ultimately, by working together around a common data standard, it means that we're effectively pooling our resources. We're hiring vendors who maybe couldn't afford to sell us a product for the price we want to pay if there's just one city, but if they can sell it to 50 cities, then suddenly the economics for them changes, and it means that they can make the kinds of big investments in technology that deliver really great outcomes for cities. So I think that's kind of at its core, a big part of what we're doing with OMF is creating a space for cities to pool their resources and investments.
Yeah, so essentially building a better wheel together instead of each person trying to recreate their own wheel with their limited resources.
Exactly.
Right.
So, Michael, can you provide more information on how MDS is utilized for enforcement and the flow that the data kind of goes through to support that?
Yeah, so there's two data flows we have. One is directly using the MDS data spec that goes into the Stay platform, and that then provides a web interface for James to use. There's another data flow that I manage, which is monthly CSV type reports of trip data, and that's what I kind of massage into open data. I'm working on converting that over from MDS to open data instead of those monthly reports. But those things, they allow, maybe I can probably list a dozen things that MDS allows James to do. So if vehicles are riding at night, based on the data, he can send them an email and say, hey, you need to stop that. If we get complaints from citizens or riders that say, hey, I was on a scooter and it was going 20 miles an hour, and we know that it's capped at 15, or somebody was riding through a no ride zone, like the American Printing House for the Blind, he can investigate those on a trip-by-trip, time-of-day basis to see some information and get back to the people, and then talk to the companies about it so they can troubleshoot their own tools and technology. We use it, as I said, for our fee management, our vehicle caps, and how we bill the companies quarterly for their deployment and usage. We use it for infrastructure planning. We use it, we give subsets of it to urban planning firms that we hire to do studies of roads, to look at usage on those roads of the devices and how, based on that usage and number of rides and where they are, where parking could be added or protected infrastructure could be added as part of that plan or that vision for the redesigned road. So that's just a few examples, but yeah, by that having those data flows, that helps us do all those things with really one or two people.
And what I think Louisville shows very well is how you can do so much with so little once you start to really leverage the power of data, if you want to call it that. Are there any lessons learned that you can provide from a city perspective about working with micromobility providers and the adoption or implementation of MDS?
I think probably the most important thing at this point, because it's so ubiquitous, is, like Jascha mentioned with the state legislation example, is when you're writing your city policy for operations, I would make sure to explicitly state MDS as how you want the data delivered to you, because that is now so agreed upon and so standardized. I don't think any company would say no to that, and with the tools available, it'll allow you to make use of that immediately and not have to then go back to the drawing board to ask for that data in the MDS spec later. And some cities have done that and they've had to readjust their policy. But beyond that, you know, there's a lot of other things to the policy outside of MDS, like about equity and pricing and fees and permits, safety, et cetera, that you also should write into your city policy around that, your operating agreement. And for that, I think looking to other cities and what they've published and their policies is probably the way to go. We published ours online. Most cities have as well. And there are some recommendations as well for what you can write into your policy from NACTO and from the Harvard Civic Analytics Network. So it's about how you can specify certain things in your policy, which I think is really helpful to have it come from higher organizations that work collaboratively with cities.
I would just add one of the lessons that I think I've certainly seen cities learn, and you know, we're sort of trying to help educate folks on. I mean, there is, even with the data standard, there is a lot of complexity in mobility data, and it's helpful for cities to kind of recognize that and be willing to learn more about it. And I'm thinking specifically about things like GPS precision, right, which is not 100%. You know, the GPS pings are not perfectly accurate. So understanding when working with data that there is a margin of error around locations. Other examples, you know, vehicles go missing, right? So when a company says the vehicle is here, most of the time they know that it's there, but there are times when a vehicle might disappear from their systems or go off their radar, and then they have to communicate that to the city, and the city has to decide how to interpret that information. So, you know, as much as data standards go a really long way towards making it easy for cities to start working with this mobility data, there's still some nuance that you have to learn a bit about and be willing to spend some time to kind of think you know, about how you want that nuance to play as you kind of map data to actual policy.
Okay, so we can open up the questions further now to both presenters there. And I know a question did come up about GPS quality and the MDS applications for regulation, right, and parking, as many micromobility companies maybe cannot afford the high definition GPS devices, or the GPS signal in sort of those urban canyons is hard to actually get accurate. You know, I've tried to pick up a traffic signal controller and found it was sitting on the other corner of the intersection just because of where I was. Are there examples of how your regulation is becoming realistic with, you know, the current technology or evolving with the technology?
Yeah, I think Jascha probably has some bigger examples from other cities, but for us, I would agree with everything Jascha said a minute ago, where it still takes some of it's still open to interpretation because of data quality or GPS issues or even some technical issues on the provider side. So when we see something erroneous like that or it can't make sense of the data, we have to spend time, which is I think fine, to reach out to the companies and ask about it. So you need to keep those communication lines open and have that representative at each of the companies that you can contact pretty quickly, because usually as a city, usually these things happen pretty quickly where you need the information or you need clarity or you're about to go talk to council about something and the data is not lining up. But yeah, there are definite things to watch out. I think and I think flexibility is important. And Jascha, I don't know if you know, I know that Portland, they were talking about requiring a certain level of accuracy of GPS or rider signal to prevent riding on sidewalks. I don't know how that's proceeding, but there has been some talk about that with some cities.
Mm-hmm.
Yeah, I'm actually not sure where that is on GPS specifically. I mean, I think there's certainly, you know, we've kind of broadly deployed GPS technology. There are certain things that are not that are hard to do or hard to do in a high accuracy way. So the example of determining sidewalk riding, right, the position within the right of way in a given space is GPS just frequently does not offer that level of accuracy. Similarly, you know, is the vehicle parked inside of a designated parking zone or outside of it is often, if that zone is small, difficult to do. So, you know, one of the things that I think you start to see is rather than in some cases where you want to think about sort of smaller geographic areas, rather than kind of regulating from a position of saying like, oh, here's a single point on a single trip that seemed to cross into a forbidden zone, you can start to look at averages over time across multiple vehicles and say, you know, we want 90% of vehicles to be, you know, to meet this threshold. And so that allows for a buffer in, you know, for GPS inaccuracies or other things. So I think what we're starting to see is cities try to bring that more kind of probabilistic lens into their calculation rather than being it, you know, it's binary in or out. But we are seeing innovation on the hardware front when it comes to other types of sensors on the vehicles. So companies are starting to deploy sensors that can tell if the vehicle is upright or tipped over, which is often a real, you know, kind of factor in terms of safety for pedestrians who might be impeded by a knocked over vehicle. I know that a number of companies are working with either machine vision or gyroscopic analytics to detect sidewalk riding. It's still, I think Lime has announced that they are rolling out commercial sidewalk detection, but they're the only company to kind of formally say that they're going to deploy it. But so we're seeing all of this sort of start to, it's a rapidly evolving hardware ecosystem. And even without hyper-precise GPS, we're still, I think, going to make progress on some of these kinds of issues.
Yeah, I think with the Portland example, there was talk of deploying, you know, hundreds of Bluetooth beacons that would help with that accuracy that GPS can't provide, which of course is expensive, could be expensive, hard to maintain and hard to manage. But it was something that was being discussed anyway. And then back to your point about averages, that's true. Like, yeah, there's always going to be these one-off trips that are miles away or last 1 second or last days, and those happen for different reasons. But when you look at it in aggregate, it's important. That's where you start to see and have your bigger questions. We had an issue where one of the providers, we looked at trips over the course of a day, over a month, and the times were not lining up to what our expectations were. And after contacting them, they had some sort of time zone issue with their data feed. So we were able to resolve that, but otherwise, you know, we might not have caught that, they might not have caught that. And when you look at it in aggregate and see those bigger issues, that's where you can talk to them and try to figure out what's happening.
Okay. So we had one question that was just looking more for the basic details on MDS. and how it works. I believe there's, both the receiving and the sending function, and wondering who are the kind of the key players that you're currently connected to right now, and getting that sort of micro-mobility data from.
I'm not sure I understand the question.
They're looking for basically details on how is the data specification working, and then who are you actually going to get that data from? Maybe some of the micromobility providers.
Got it. So you can find some of the more technical details are on our website. If you go to our GitHub page in particular, you'll see for Mobility Data Specification, you can kind of get into the nitty-gritty details of how it works. But typically the way that it's deployed is for data gathering is in one of two ways. The most common is something called the MDS provider interface, and that is an API that is created by the micromobility companies who are operating in a given jurisdiction that the regulator can query to get data about trips or things happening with vehicles in the right-of-way. So a regulator would be able to make an API call using a commercial tool or using an open source tool, hit an API that is operated by the mobility company to extract that data. There's another design model which there's a different API for called the agency API. And in that case, the regulator would actually host an API and the mobility company would push events and information to that API as it happens. So if a scooter is unlocked, it would push an event saying the scooter's been unlocked. If the trip ends, it would push an event saying the trip ends. That design pattern is more complicated for the regulators because they have to actually operate an API, but it offers, in some ways more flexibility and certainly more, it's designed around real-time applications. So we are, depending upon kind of your goals and use case, one might be better than the other. We're about to publish a guide to help people choose between those two models. What we see for the vast majority of our cities right now is they're using the MDS provider interface, which is something that pretty much every micromobility company that's operating on city streets already supports.
And we had a question whether MDS is or would be capable to analyze connected infrastructure like Bluetooth beacons for location.
It's not built for that today. If, for example, you had Bluetooth beacons and scooter companies were putting the appropriate hardware to interface with those beacons on their devices, that might enable a scooter company to report back more accurate or more precise information in their MDS feed. But in many ways, MDS is sort of ignorant of the mechanism by which data is like location information is determined, right? We get longitude and latitude. Now, generally that's coming from GPS, but there's nothing that would prevent an alternate mechanism from being used.
And so I think you mentioned that MDS is there, and that's one of your first key sort of specifications that you started on, but that you're also working on many other sort of applications or specifications for this sort of collaborative city use. Are any others already open to be shared, or is MDS still the main one that's out there?
Yeah, MDS is still the main one, and I would say, we haven't, for most of these things, we haven't yet started working on them in a kind of building APIs perspective. I think where we're at with some of these things like ride hail, like freight, is we're focusing our energy on exploring the policy goals that cities have so that we can begin to develop APIs and data interface mechanisms that can further those policy goals. We really think that any work we do in this space has to start from that place of what it is that we want to accomplish for the public, and then we want to bring all of the different stakeholders to the table, including private sector folks, to help figure out what kinds of data and what mechanism are most useful to advance those policy goals. So that's kind of the stage that we're at with a lot of these other things.
Yeah, one of the other.
There are some people using MDS for other things, right? Like I've heard of it being used for some car share,
Yes.
and maybe ride hail in some capacity, but I'm not sure about that.
Yeah, car share is actually a pretty straightforward additional use case
Yeah.
because the model is dockless or point-to-point car share really resembles dockless mobility almost precisely. I think one could, and there may be a few examples of people using it in the context of ride hail. I think it's not well optimized for that, and while some policy questions might be answerable through MDS in its current state when it comes to ride hail, there's a lot of really critical policy questions like vehicle occupancy, like driver time on the road, independent of productive revenue trips, that are that the data standard is not optimized to answer at this point.
Correct.
So one of the other items that I saw from the presentation was just the fact of cities having a good understanding of their own digital infrastructure as they embark on this item in order to, better understand restriction zones, to better make those analyses. Any other comments on that?
Jascha, can you rephrase that a little bit?
Well, I was just noting that in order to start to make use of a lot of this information, it's useful for a city to have a good digital infrastructure of their, say, available assets, their streets, their various regions to help support the various analysis.
I don't know. I mean, it's useful to have that. I think because the data from MDS, for example, comes in latitude and longitude, you can put that information into any number of GIS or open source tools to visualize it and make sense of it and do analysis on, times and ride length and all sorts of things without having to even really know about your own infrastructure. An example of that is, we have the paths of every street in the city, but we don't have the width of the street or the lanes or the turn radiuses or anything like that. Some cities have that. We are just now geocoding all of our parking meters, which we didn't have before. We have sidewalk locations, but again, not width, or we have some quality information. So I would say, even though you could have some or all of that information about your city, and I don't know if it necessarily helps out in this case. I think it can help out in a few scenarios, but for the most part, you can operate independently without that information. At least that's what we're doing here in Louisville.
Yeah, I mean, I think, cities are all in different stages of maturity and data quality when it comes to, the rest of their assets. And, from my perspective, and certainly when I, putting on my hat as CIO and thinking about the data team that we built, you can't let the perfect be the enemy of the good with this sort of stuff. I mean, it would be nice if we had digitized every asset, and there's certainly work to be done, but simply bringing data, ingesting data, understanding what questions you can answer today, and then if there are questions you can't answer because you don't have those additional that additional asset information, doing that kind of cost benefit analysis of how difficult it will be to get, and then trying to apply that. I mean, it's sort of your standard stuff, but at the end of the day, there's no sort of, you must be at least this sophisticated in your data before you can start getting value out of this. The sooner you start learning and building the muscles to use data in policymaking, the better. And you will make much better decisions about what additional data to capture and how to integrate it when you do start from that place of already having your feet wet with whatever data you can get easily.
Great. Well, thank you both for taking the time to come and speak with us. I know we've had a variety of people from all over the country, from public, private, and academia on the line. So it's good to have you both share, the work that you're doing and how you're working to bring people together to really try and build that better wheel, and not doing that separately. Just a reminder, both presenters have graciously approved sharing the presentation. So after the presentation, we will stick that up on YouTube under ITS Canada's YouTube account, and that might be linked off of ITS Canada's website as well. Just wanted to remind you of a few different items upcoming, a few webinars talking about road weather information systems in February, improving bus prediction with machine learning in March. As well, we're talking about another traffic management related connected autonomous vehicle webinar to become, and we're looking maybe late March or early April for that. And as well, we have the ITS Canada conference coming up. So on behalf of Jonathan Darton and myself and ITS Canada, thank you very much, Michael and Jascha, for spending some time with us. Feel free to get in touch with those on the call if you have further questions, or check out OMF online or their GitHub for further information. And I'm sure you can find Michael Schnuerle on the web and find out more of what they're doing with Open Government Coalition. All right, thank you all for your time, and take care.
Thank you for hosting.
Thank you.